Question number 5. A parachutist falls from a stationary balloon with time t equal to 0. The VT graph of the parachutist at from time t equal to 0 until the time when he is just above the ground is as shown. Okay. The graph shows the variation at time of the acceleration of the parachute. Okay. So now, right. Acceleration of the parachute. So acceleration to which graph shows the variation at time of the acceleration of the parachute. So that's what is the question. Okay. So given VT graph, find the corresponding AT graph. That's a simple thing. Now towards it, if you look at this here, the velocity is increasing. That means acceleration is there, but the rate at which the velocity is increasing is decreasing, right? So therefore, here you can say the acceleration is decreasing over here. Here what happens? The acceleration equal to 0 here. Here what happens? The acceleration, the velocity is here, velocity suddenly decreases over here, okay, in this region QR. So therefore, here acceleration increases abruptly but negatively because velocity is reducing, right? Velocity reduces, deceleration is much higher. That's what I can say. Then R2S, what's happening? A is equal to 0 here. Now we need to figure out from these 4 graphs which regions are correct over here. Now here you see A is decreasing. A is decreasing. So this will correspond to A decreasing. So this is right. Here also B is also the same way. C is not showing that, right? Because you see when you drop from here, acceleration was 0 and acceleration was maximum, and after that acceleration start to reduce and reach the 0 value here. Okay, so here acceleration was maximum and acceleration becomes 0. Here acceleration is minimum, acceleration is negative. So therefore this is not possible, this is not possible. So these two graphs I decline to say. Reason is because acceleration is negative. Now you are left out only with 2 options here. Okay, which of these are correct? Now acceleration equal to 0, acceleration equal to 0, PQ region, that's shown clearly here. Then acceleration reduces, okay, acceleration increases but in a negative way. Acceleration increases but in a negative way. Both of them are showing the same thing. Acceleration equal to 0, acceleration equal to 0. So A equal to 0 here, A equal to 0 here, A equal to 0 here. All the regions are fine, okay, very similar to it except for this region, this region. Now what is so special about it? If you look at this once again here, see the velocity is here so much and suddenly velocity drops down. Okay, so velocity suddenly drops down here, which means the decrease in velocity is much higher, okay, as compared to the increase over here, right? The time taken for the decrease, see, it takes a longer time from O to P, it takes a longer time over here, okay, to start from 0 and to reach this point. But if you take this point and this point over here, it takes a very short time. Here if you take this time T2 here, T2 and T1, T2 is much smaller, okay, for the same decline. Now which means, see what is this now? Changes in velocity value. Changes in velocity value could be reflected here, So as a result of this, so as you see here, okay, this one will have a larger length as compared to this, and hence B is the right answer. Okay.